Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on the video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. Now, let's get started. In this video, we're looking at Unit 1 on constructions and rigid transformations, Lesson 8, using technology for constructions. The learning goal in this lesson is to use technology to construct a diagram. And the technology we will be using is the GeoGebra Geometry website. The learning target for this lesson says that I can use technology to help me construct specific diagrams. When we get done with the practice problems, we will come back and review this learning target and make sure you understand everything you need to before moving on to the next lesson. The glossary terms that we'll need to know in this lesson: angle bisector is a line that splits an angle in half, creating two equal angles. So maybe we assume this original angle was about 80 degrees. The angle bisector turns it into two 40-degree angles. Next up, we have circle. A circle is simply a collection of points that are all the exact same distance from the center point. That distance from the center point to the circle itself is known as the radius. Because all of the points are the same distance from the center, then every radius is also the same length. Next, we have conjecture. This is simply a reasonable guess based on the data that you have that you then try to either prove or disprove. Next, we have inscribed. On the left, you'll see an image of a polygon inscribed inside of a circle, meaning the entire polygon fits within the circle and every vertice or every corner is actually touching the circle. On the right side, you see the exact opposite. This is a circle inscribed inside a polygon. The circle fits completely within the polygon, and every single side of the polygon touches the circle in one point. Next, we have line segment. Instead of a line which goes on in both directions to infinity, a line segment is actually defined by its two endpoints and only consists of all the points in between those two identified endpoints. Next, we have parallel. Parallel lines are lines that will never intersect. They'll never touch. They'll never cross. They just run side by side to infinity in both directions. If you have two parallel lines, then you can take two segments out of those lines, and those line segments will also be parallel to each other. Next, we have perpendicular bisector. The bisector part of this means that it cuts a line segment exactly in half. The perpendicular part means that it does so at a 90-degree angle. So as you can see in this example, we have line segment AB. The dashed perpendicular bisector cuts it in half and it cuts it in half at a 90-degree angle. And our last glossary term for this lesson is regular polygon. Adding that term regular in front of polygon means that every side is the same and every angle is the same. And when we're talking about things being the same, we use the term congruent. Now let's take all of this information we have and get started on the practice problems for Lesson 8. Practice problem number 1 in Lesson 8. Select all of the digital construction tools that do the same job as a pencil alone, without straight edge or compass. Now, the first time I read this and I looked at GeoGebra, which is the tool that we're going to be using in this lesson and that these questions are going to be referring to, my immediate response when something is referred to as a pencil, if we look at GeoGebra, I would be thinking of the pen tool, where I can simply draw what I want to. Then there is also the freehand shape. Again, it lets me just kind of draw what I want to, and then it turns it into a shape. But if you look at our answers, those choices are not given to us. So we've got to figure out what they mean in the GeoGebra tool as being a pencil alone without straight edge or compass. So if you go to geogebra.org/geometry, if you click on, this is what it looks like originally when the page loads. And if you click on more, you'll begin getting these extra tools. And if you scroll down to the bottom, you can click one more time, and it'll give you all the possible tools. So if you look through, you'll start to see some of the choices they give us. So let's look at the line tool. Right here, under the lines category, we see this line tool that looks like 2 points and a line going through it that continues going in both directions. If you click on that, you use the tool by clicking on any point once, and then as you go out from it, you'll notice it gives you this straight line. Well, now you can pick a second point, click again, and now it draws this straight line for you between those 2 points. So in this case, they would consider this as using a straight edge. And remember, back up at the top, they wanted without straight edge. So E would not be a correct choice for this question. The next tool I would like us to look at is choice B, polygon. If we continue to scroll down on the left side, under the polygons category, this very first choice is polygon. It looks like 3 points with a shaded triangle connecting them. Now, when we're using the polygon, we can select a first point. You'll see that as I move my mouse around, I get a straight edge coming out from that first point that I made. So now I can pick a second point and click one time again. And then you'll notice as I pull away, I'm starting to get a shaded area and another line. So if I were to pick a third point and then move my mouse, same thing. I get another line and I get a shaded area. Now if I were to go back and click on that first point, that would close the polygon. But notice, now I'm getting a shaded area with those straight edge lines. So because this did utilize a straight edge tool, that's not what we were looking for on number 1. We wanted to not have a straight edge. So therefore, polygon is going to be wrong because of that built-in straight edge. The next tool I want us to see is choice C, circle with center through point. So if we come back to GeoGebra and scroll up, under the circles category, we have this circle with center. Notice that it does have this one point on the circle itself. So we're going to click on that once. You'll notice in the bottom left, it tells you circle with center through point. Select center point, then point on circle. So you're going to go somewhere on your graph and you're going to click once. That is going to set the center point. Now, as you start to drag away from that center point, you'll notice it's giving you a circle. So you're going to go to any new point and you're going to click again. And that has created your circle with point, because you picked the center point of the circle and then you picked a point on the circle itself to set the size. Now, they would consider this as using a compass tool. And if you remember in the instructions, it said without straight edge or compass. So because this one would be considered a compass tool, this would not be a correct choice. So now we're down to A, point plotted on an object, and D, point of intersection. So let's look at those tools. First, we have point on an object. It's on the points category here. So if we click on that tool, it says select object or its perimeter. So I'm going to click on the circle. And that's going to put this point C on the circle itself. I could also put one somewhere inside the circle. Now, if I were to go back up here and choose the move, I can grab the circle and move it. And notice that the point that I put on the circle now moves with the circle wherever I put it. But point D, because I put it inside the circle and the circle is not filled in, it doesn't move. It stays where it was. Now let me show you something different. Let's go back and choose this polygon tool. And I'm going to make a square. Now that we have our square drawn, I want to go back up and I want to show you this point on object again. But this time, we can put one on the square itself, just like we did the circle before. But now I want to put one inside the square. Now, when we did the circle, it was not shaded in. So the shape itself was really just the outline of the circle. So the point on the circle moved, but the point inside the circle did not. Now that we've drawn a polygon and it's shaded in, if we scroll back up and use the move tool, now I can click on this square and drag it around. And as I drag it around, even the point on the inside moves with it, because now it's actually part of the shape because that shape is shaded in. So this one, the point on an object tool in GeoGebra is considered to be doing the same job as a pencil without a straight edge or a compass, because it's really just allowing you to plot points like you would with a pencil. It's not actually creating the straight edge shapes for you. It's not actually creating the compass shapes for you. So A would be a correct answer for this one. Our last one to look at is point of intersection. So, as we look at this, what we can do to use the intersect point, first you need to draw a couple of lines or some shapes. I'll even draw a couple of segments here. So up here under basic tools, I can click on segment, and I'm going to draw two segments that cross each other. Now, when I scroll back down to points and I choose intersect, notice it says select intersection or two objects successfully. So I could go right here where I see them intersecting and I could click, and it'll give me a point at the intersection. Or I can make sure that I have intersect selected. I can pick anywhere on this first line. Then I can pick anywhere on this second line, and it will calculate where they are crossing and put the point for me. But notice, it's only creating a point, kind of like I would take a pencil and just draw a point. It's not actually giving me a straight edge. It's not actually giving me a compass drawing. So therefore, choice D, point of intersection, when it comes to GeoGebra, is considered as doing the same job as a pencil alone without straight edge or compass. I hope this explanation has made sense to you. If you still have questions, please feel free to leave a comment below. Practice problem number 2. How can you test to see if a diagram made using digital tools is a construction or just a drawing based on estimation? So let me show you what they mean by this. I've set up an example here where in the middle, this line that is drawn through points A and B was created using the basic line tool. Now, if you scroll down on the left, we have this category called construct. And you'll notice that one of the tools is a parallel line. What you do is you click on it, and then you simply click on the line that you want to make a parallel line of, and then you click anywhere else on the screen, and it will create a parallel line going through that point parallel with the original line that you selected. So what I've done is one of the lines, either line CD at the top or EF at the bottom, was created by using this parallel line construct. The other one was created by using the line tool again and just estimating where a parallel line would go. And they're asking, how can you tell the difference? So what you want to do is you want to click on the Move tool. And if you notice, I said line AB was created using the line tool. If I click on A and I move it, notice what happened. By moving my original line, my line that was created using the construct also adjusted to remain parallel. But the line I created on the bottom using the line tool did not move because it is not a construct of that middle line. So when you use a construct tool, they will adjust as you move the original. So that's what we'll put in the answer. If a diagram is made using a construct, it will move to adjust as you move the original. A drawing based on estimation won't move as you move the original. So that is how you can test and tell the difference between the two. It's also why, if you need to make, say, perpendicular lines or parallel lines or perpendicular bisectors, you really should think about using those construct tools, because then you're able to make adjustments to your original line and your construct will adjust to maintain whichever line it was that you were trying to create in the first place. I hope this makes sense to you. If you still have any questions about this practice problem, go ahead and leave a comment below. Practice problem number 3. Han thought he constructed a rectangle using digital tools. When he moved point A, the screen looked like this, meaning the picture on the right. What did Han do wrong? I'm going to show you what happened. What Han did was Han used the polygon tool. So if you take the polygon tool, I could make a rectangle by simply clicking 4 points and then closing it back at the start. The problem with this is that now, if I do like Han did, and I grab one of the points and I move it, this is a polygon, not a rectangle. So I can move it around into different shapes that are not going to be rectangles. Remember that a rectangle needs 2 sets of parallel lines, and it needs to have 90-degree angles. If I want to create something that will always be a rectangle, even if I change its size, what I can do is I can take a line or a line segment and create my first line. Now I can go down to the construct tools and I can say that I want perpendicular lines. I have to select the line or line segment that I want it perpendicular to, and then I need to pick a point to place it. Now I can go back and I can select that original line again, and then I can place another corner. And then I can either use the perpendicular line and select one of the sides and then place it, or I can switch to a parallel line, click my original, and then say that I want it to be parallel here. Now, what I've done is I've created it so that the left and right sides will stay parallel to that original line, or will stay perpendicular to the original line and stay parallel to each other. And then the bottom line will stay parallel to the original line. So now if I use my move tool and I start moving G, it's going to make it where it stays a rectangle because my lines are going to stay parallel to each other and they're going to stay at 90 degrees. So this is what Han did wrong. So for the answer, we can simply write he used the polygon tool instead of construct tools like parallel lines or perpendicular lines. So you just have to choose the tool that is going to create exactly what it is that you want to create. I hope this makes sense, the difference between the polygon tool or the parallel line tool, the perpendicular line tool, which are considered construct tools. If you still have any questions, please leave a comment below. Practice problem number 4. Select all the digital construction tools that do the same job as a straight edge. Now, we've actually talked through these tools in a previous problem when we were looking for the ones that act like a pencil without straight edge or compass. This time they want us to find the ones that actually act like a straight edge. So if we look at choice A, we have circle with center through point. If you remember, this tool actually acts as a compass. It helps you draw the circles. So A would not be a correct answer. Choice B, point plotted on an object. This was the point tool where you could put it on the line of a shape, or if you had drawn a shaded in shape, you could put it in the shaded area, and then when you moved the shape, those points would move with the shape. Either way, it acts as a point, not as a straight edge. So B would not be a correct answer. The next choice, C, point of intersection. This is when you take any two lines or shapes and then you select on them and it calculates where they are intersecting and it draws a point. So again, this is a point tool, not a straight edge. So C would not be a correct answer. Choice D, segment. This is when we would plot 2 points and then it would draw the straight line connecting those 2 points. So this tool actually does draw a straight edge, so therefore D is a correct answer to this question. And then finally, choice E, line. This is a lot like the segment tool, but instead of stopping at the 2 points you choose, it actually extends completely through those 2 points as a line rather than a segment. But again, it does result in drawing a straight edge. So E would also be a correct answer to this question. If you have any questions about this practice problem, please feel free to leave a comment below. Practice problem number 5. This is just like the one we did before and the one we did at the beginning, where they're giving a list of the tools and they want us to find the ones that do the job of a certain tool. So we've already talked about which ones act like a pencil because they give you a point. We've talked about which ones act like a straight edge because you can draw lines and segments with them. This time what they're asking for is which digital construction tool does the same job as a compass. That means it's going to allow you to draw curves and circles. So choice A says point. Well, this is going to act like a pencil because it's going to give you that point. It's not going to give you a curve or a circle, so A would not be a correct answer to this question. Choice B, line. The line tool is where you pick 2 points and then it draws the line that goes through both of them. This acts as a straight edge, not a compass. This is not going to give you curves and circles. So B would not be a correct answer. Choice C, the polygon tool. We've used this previously. This is where you can pick points. It will connect those points with straight lines, and then when you finish the shape, it will shade the shape in. Again, this one results in drawing straight edges, not curves and circles like a compass. So C would not be correct. Choice D, circle with center through point. This is the one where you can pick your center point, then move out and pick where your circle is going to be, and it will draw the center point, the circle, and a radius between those 2 points. So this is going to give you the circle, which is what a compass does. So D would be the correct answer. I hope this explanation has made sense to you. If you still have questions, though, please feel free to leave a comment below. Okay, let's take a look at practice problem number 6. This diagram was made using digital construction tools. One of these triangles was made using the polygon tool, and the other was made using the regular polygon tool. Explain what you could do to tell the difference between them. So the key word here that I need you to notice is when they refer to it as a regular polygon. Anytime you see them use that word regular, it means all sides are the same and all angles are the same. So let's take a look at what the difference between these two tools is. We're going to go to GeoGebra. And if you scroll down on the left side, when you get to the polygons category, first you're going to see polygon, which we have already used. If I were to take it, I just click a point, I click a second point, and I just make a shape. And when I'm done making my shape, I click back in the original point, and now I see that I have a square that's shaded in. So this is the entire square. Now let's take the regular polygon and let's do the same thing. We're going to click a first point. We will click a second point, and this time it's going to ask us how many vertices do we want. Vertices are corners. Since we're drawing a square, we want 4 vertices. So we'll hit OK. And we can see that it drew a square. So now the question is, well, how do I tell the difference between the two? Scroll back up to the left on the top and click your Move tool. Now go and grab one of the points and move it around. Notice that with the polygon tool, the other 3 points, B, C, and D, all stay exactly where they were. The only thing that's changing is the point that I'm grabbing, because this is drawing any polygon. The sides don't have to be the same. The angles don't have to be the same. However, if I grab that bottom left corner on the regular polygon tool, as I move it, the other points also move, because wherever I move this first point, all the other points have to move to maintain sides that are the same and angles that are the same. So this is how we can tell the difference. So on our worksheet, what we want to say is that we could drag a point on each triangle. Once we drag a point on each triangle, what we'd see is that the polygon tool only moves the point we drag. The regular polygon tool moves all the points to maintain sides and angles that are all the same. I hope this explanation makes sense to you. Go ahead, get on GeoGebra, try this out so you understand it better. And if you still have any questions, please feel free to leave a comment below. Practice problem number 7. Which digital construction tool would help you determine whether point C or point D is the midpoint of segment AB? So for this one, we're assuming that you've already drawn this digital circle. Maybe you used the center with point tool. And now you're trying to figure out, does my midpoint go where point C is or point D is? And they give us 4 choices. The first choice they give us is angle bisector. Well, an angle bisector is going to take an angle and it's going to divide it in half. But we don't have an angle here. We have a straight line segment, and we're trying to find the middle of that line segment. So because we're not looking at an angle, A would not be correct. Let's look at point C. Perpendicular line tool. Now, a perpendicular line tool is going to ensure that you have a line crossing the original line at exactly a 90-degree angle. The problem is, it could be anywhere. It wouldn't have to be in the middle. So because it doesn't have to be in the middle, C is not going to tell you where the midpoint is. The last choice they give us is parallel line. Well, remember, parallel lines are lines that run side by side and will never touch or cross. So this isn't even going to touch line segment AB, so there's no possible way that it could tell you where the midpoint is. So D would not be correct. What we want to use is choice B, the perpendicular bisect, because this must be in the middle. And that is how we're going to find which of these points is the midpoint. So B would be the correct answer. I hope this helps you understand these digital construction tools a little bit better. But if you still have any questions, please feel free to leave a comment below. Practice problem number 8. Here is a construction of a regular hexagon, meaning all 6 sides are the same length, all 6 angles are the same measurement. Inscribed in a circle. Not all parts of the construction are shown. Explain how to construct an equilateral triangle, meaning all 3 sides are the same length, all 3 angles have the same measure. Inscribed in the circle, centered at A, using digital construction tools. So let's go to GeoGebra. Now, we know that it's a regular hexagon. So I would come to the polygons menu, select regular polygon. I'm just going to pick 2 points. And then I'm going to tell it that I want 6 vertices so that I have 6 corners and 6 sides. Now that I have my regular hexagon, I'm going to use circle with center. I'm going to find the center of this hexagon, plot my first point, and then I'm going to come out and make my second point one of the vertices of the hexagon. So now I've constructed what they gave us, a regular hexagon inscribed inside a circle. Now they want to know, how could you do an equilateral triangle? Well, because we know that this hexagon is a regular hexagon, then what we can do, normally you would think regular polygon. And this will work, but only if I choose the lowest points. So I could say point F to point B, tell it that I want 3 vertices, and it will create an equilateral triangle for me. But when you use this regular polygon, it is always going to try to make the triangle go this way. So if I tried to do it again for A, C, and E, then if I tried to pick A and C, it'll work. But if I tried to make C and E, it also works. Sometimes what it does is it will actually make it go outside the circle. So you could use the regular polygon tool. Sometimes it'll work for you, sometimes it won't. The other thing you could do so that you have complete control is I could use just the polygon tool, and now I can pick any points. I can go F to D to B and then close it out. I could go A, E, C and close it out. But it gives me complete control of where I want to draw the triangle. Here's an example of what the regular polygon might do sometimes. Notice this time when I picked E and C, it made my triangle go outside of the circle. So while the regular polygon tool will work sometimes for you, sometimes it makes it in the wrong direction. So my recommendation, if you know this is already a regular polygon with the hexagon, then you can go ahead and just use the polygon tool so that you have full control over where the entire triangle gets drawn. So let's go back to the worksheet, and we will say use the polygon tool to connect points B, D, F, or points C, E, G. So that would either give us a triangle here, or it would give us a triangle. Here. In both cases, we create an equilateral triangle. I hope this helps you understand how to use the tools better. I hope you see that sometimes the regular polygon tool is going to be the one that you want to use, but you have to get used to how to use it because sometimes it will actually create that regular polygon in a direction other than what you were hoping it would. So sometimes you may have to go ahead and use just the regular polygon tool so that you are determining where each of the points in that polygon go. If you still have any more questions about this practice problem, please go ahead and leave a comment below. Practice problem number 9 is going to be the last practice problem in this lesson. Here's a construction of a regular hexagon inscribed in a circle, just like the previous problem. Again, not all parts of the construction are shown. Explain how to construct a regular 12-sided polygon inscribed in the circle centered at A using digital construction tools. So let's go take a look. Here I've gone ahead and I've constructed the regular hexagon inscribed inside a circle. Next, we need to understand how to create a 12-sided polygon. Now, if you scroll up on the left side and you look at your constructs, the first one that caught my eye was midpoint or center. But in this case, if I tried to use midpoint and I picked 2 points on the hexagon, it gives me the midpoint, but it gives me the midpoint on the hexagon itself. And I don't want to inscribe a 12-sided on the hexagon because it's just going to look like the hexagon. I need this point to be out on the circle. So instead of using the midpoint, what I'm going to do is I'm going to use the perpendicular bisector tool. And now I can go around and just select the sides. Side A to B, side B to C, and side C to D. Now, we could do all 6 sides, but because these perpendicular bisectors go all the way through, you only need to do 3 sides to have all of them done. Once we see this, what we can do is we can scroll to our points and choose intersect. And then what I'm going to do is I'm going to pick one of those bisectors and the circle, and it's going to give me the point at the top and the point at the bottom. Then I'm going to pick the next bisector and the circle, and now I get this point K and this point J in the bottom right, and I'll select the last bisector and the circle, and it's going to give me points L and M. Now, what I want to do, simply because it's starting to get a little busy, there's a lot of stuff showing up here, you can go up to the Edit category and click Show or Hide Object. So I'm going to click on each of the bisectors, just so that it hides them. Now I'm going to scroll down to polygons, and I'm going to choose regular polygon. You can do this with regular or with just polygon. If I do regular, then I'm going to select points A and H. I'm going to tell it I want 12 vertices, and it draws in the 12-sided polygon. If I wanted it to be a little more clear, we could try to also hide that 6-sided shape. It's a little hard to get it to pick the right one. But regardless of whether we can hide it or not, we can now see that the 12-sided shape is in there. So this is how we would do it. So we'll go back to the worksheet. The first thing we needed to do was use the perpendicular bisector tool on each side. Then mark the points where the bisectors cross the circle, then use regular polygon or polygon to join the 12 points. So I hope this gives you a little better understanding of how to use the perpendicular bisector tool, how to use the polygon and regular polygon tools. But if you still have any questions, feel free to leave a comment below. Take some time on GeoGebra and just practice with all the tools. Make sure you understand how to use them. See how they can help you possibly do practice problems in the future so that you get comfortable with it. Now, before we end this video, let's go review the learning targets and make sure you understand everything you need to before moving on to the next lesson. In conclusion, let's sum up this learning target. There was only one for this lesson, and that was for you to be able to use technology to help construct specific diagrams. So in this lesson, the technology we were using was the GeoGebra website. And specifically, we used the geometry page from that website. And hopefully you better understand how to use point tools, line tools, compass tools, polygon tools, understand better how to use perpendicular bisectors, parallel lines, things like that. The difference between simply drawing the shapes yourself versus using the construction tools, because the construction tools will change all of the lines as you move one point, whereas if you just draw each line individually, it doesn't do that. The difference between the polygon and the regular polygon tool: with a polygon tool, when you drag one point, it only changes that point. But with a regular polygon tool, because all of the sides need to remain the same and the angles need to remain the same, then as you drag one point, the other points also move. So just make sure you understand how to use all these tools. Take some time, practice, use all the different tools, even the ones we didn't talk about today, just to get used to how to use it, because you may need to in future lessons to help you understand things better. I hope everything we talked about in this video makes sense. If it did, in the bottom left corner of the screen, you should see another video that YouTube is recommending. In the bottom right corner of the screen, you should see the subscribe button for the channel. Please subscribe to the channel. Give this video a thumbs up. Engage with a comment below. And I look forward to seeing you in the next lesson.